Okay, this is the last one. This is example 611, and there's a correction to this one because we can't use example 6.7 with the naphthalene for C10 and H8. It's not found in the reference booklet, and I would much rather you be doing one that's actually found in your reference booklet. So instead, we're going to use our equation from example 6.9, which was the heat of formation of NO gas from its elements. And I'll flip back to show that one to you, if you recall. Example 6.9 was our Hess's Law problem, and we ended up with half N2 gas plus half O2 gas yields NO gas, and a calculated delta H of 90.25 kilojoules. So we're going to use that equation. So let's come back over here and first write the equation. Half N2 gas plus half O2 gas yields NO gas. And again, what we're going to do here is, what the beauty of this one is repeating one we did using Hess's Law, is you'll be able to see that you'll obtain the same values, numeric values for this one, as you did in the previous problem. So Hess's Law and standard enthalpy of formation are companion methods. So you can use Hess's Law or you can use standard enthalpy of formation. However, on Friday's test, I'll be very clear. There'll be questions where it will clearly say using the technique of Hess's Law. So let's start by looking up our values. So once again, we're back into our booklet. Nitrogen, N2 gas, again, it's an element, so its value is going to be 0. Oxygen right below it. O2 gas, its value is going to be 0. So I've confirmed both of those. And the other substance we have is NO gas, which is right here, going straight across. Its value is 90.3. So let's come back over here. We have a 0, and a 90.3. And now we're ready to set up our reaction. You can see by these values, the math here is going to be pretty simple and straightforward. Delta H equals sum of the products minus sum of the reactants. So for the sum of the products, this is technically a coefficient of 1, so it's 1 times 90.3 minus the sum of the reactants, and just for argument's sake, we'll show what this would look like. It'd be a half times 0 plus a half times 0. And we all know that a half times 0 and a half times 0 is going to drop out. That term's going to be 0. So we end up with delta H is equal to 1 times 90.3. So delta H equals 90.3. And again, how about our units? Let's come back here to our table. The delta H's are in kilojoules per mole, but the times 1 and the times halves were in moles, so this is straight kilojoules. And you can emphasize it by placing the positive value in there if you'd like. So the delta H, according to standard enthalpies of formations from our standard tables in the reference booklet, is positive 90.3 kilojoules. And again, jumping back here to our Hess's Law equation, exact same equation, much more complex calculation. Final answer, positive 90.25 kilojoules. Only difference there, sig figs, and how many digits you were provided on these values compared to how many you were provided by the standard enthalpy of formation table, but numerically the same. So as you can see, we are now finished. What's remaining? Last night you were supposed to have completed homework number 3. When you come in on Wednesday, we're going to check homework number 3 as well as homework number 4. You can see homework number 4 has Hess's Law problems as well as a Hess's Law worksheet associated with it, which you will receive now. Homework number 5 is the heats of formation, the technique that we just did today. So essentially you can move forward and complete both homeworks 4 and 5 this evening if you choose. But I'm not giving you double homework. Homework 4 is assigned for this evening, homework 5 for tomorrow evening, and we'll go over the answers to homework 5 on Thursday. Homeworks 3 and 4 we will go over on Wednesday, test on Friday. Just to make sure we're clear about everything we should have completed by now, this was part of homework number 1. Everything was done except question number 2, which we're going to use as part of our review on Thursday after we go over homework. Also on the back of this page, it says mixed review. And there are 2 additional problems here, 1, 2, which we'll use as extra review and practice for Thursday during class as well. And that'll bring things to a close. If there's any questions, I'll be back tomorrow, and we'll also have Thursday as a review day.